Hello viewers, in today's class we are going to discuss one important definite integral involving greatest integer function, right? So here we have this problem, that is we have to integrate this function, which is greatest integer function of x square minus 2x plus 5, and the limits are from 2 to 3, right? So here this is a quadratic function, right? And we are going to solve this problem by the method of substitution, right? I have solved this problem in one of my videos, but in that video we have adopted a different method, right? But here I am solving it just for the sake of further knowledge and how to solve this problem with the help of substitution method, right? But in that video I have used the method of inequalities, right? So for further knowledge you can also go through that video, right? So now let us solve this problem by method of substitution, right? So let us take t is equal to x square minus 2x plus 5, right? Now when t is equal to x square minus 2x plus 5, then obviously dt over dx is equal to 2x minus 2, right? So now this is our first equation, and see, since we are using the method of substitution, so let us change the limits, right? So when x is equal to 2, we see that the value of t is 2 square minus 2 times 2 plus 5, that is 4 minus 4 plus 5, that is 5, right? And when x is equal to 3, we have t is equal to 3 square minus 2 times 3 plus 5, and we have 9 minus 6 plus 5, that is 8, right? So when x varies from 2 to 3, then t varies from 5 to 8, right? Okay, now let us once again observe this expression, right? So here we can call this as equation number 2, and this is expression number 1, right? So now this expression can be written as x square minus 2x plus 5 minus t equal to 0, right? Now we see that this is a quadratic equation, in x, right? And if we compare this equation with the standard equation ax square plus bx plus c is equal to 0, we see that a is 1, b is minus 2, and c is equal to 5 minus t, right? Okay, now we'll solve this quadratic equation with the help of quadratic formula, and the quadratic formula is x is equal to minus b and plus minus square root of b square minus 4ac over 2a, right? So now x is equal to minus 2, so we are substituting the values of a, b and c, and we have here b square, that is minus 2 square is 4, and minus 4 times a is 1, and c is 5 minus t, right? And we have 2 times 1, right? Okay, so now we have x is equal to 2 plus minus square root of 4 minus here we have 20, 4 5s are 20, and plus 4t, and here we have 2. So now we can write it as 2 plus minus square root of 4t minus 16 over 2, right? Now taking this 2 to multiplying this 2 with x, we have 2x is equal to 2 plus minus square root of 4t minus 16. So now we have 2x minus 2 is equal to square root of 4t minus 16, right? So here we have a very important result, that is 2x minus 2 is equal to square root of 4t minus 16. Now this expression number 2, it gives us dt over 2x minus 2 is equal to dx. So now dx is equal to dt over this expression for 2x minus 2. So we have square root of 4t minus 16, right? Okay, so now this expression or this integral can be written as I is equal to from t is equal to 5 to 8, and for this we have greatest integer x square minus 2x plus 5 can be written as greatest integer of t, and for dx we have dt over square root of 4t minus 16, right? Okay, so now we have to solve this integral. Now viewers, let us observe the lower limit and upper limit. So here t varies from 5 to 8, and if we plot these 2 points on the real number line, we see that here is 5 and here we have 8, right? And between 5 and 8 we have 2 more integers, and the integers are 6 and 7, right? So what we will do now, we'll break this integral as a sum of 3 integrals, right? So we can write it as I1 plus I2 plus I3, right? So I1 is from 5 to 6, then I1 is from 5 to 6, I2 is from 6 to 7, and I3 is from 7 to 8, right? And moreover, when t lies between 5 and 6, then the value of greatest integer t is equal to 5, and when t lies between 6 and 7, then the value of greatest integer t is equal to 6, and when t lies between 7 and 8, then the value of greatest integer t is 7, right? Okay, so now I1 can be written as integral from 5 to 6, and we have for greatest integer t we can write 5, but let us write this way. So we have here this integral, right? And I2 is from 6 to 7, we have greatest integer t dt over square root of 4t minus 16, and I3 is from 7 to 8, right? And we have greatest integer t dt over square root of 4t minus 16, right? Okay, so now for this greatest integer t, we can write 5, and for this greatest integer t we can write 6, and for this greatest integer t we can write 7, right? Okay, so now these three integrals can be rewritten as 5 to 6 we have 5 dt over square root of 4t minus 16, and here we have 6 to 7. For this we have 6 dt over square root of 4t minus 16, and for this we have 7 to 8, and here we have 7 dt over square root of 4t minus 16, right? Okay, so now we have the integrals. Taking 5 outside, the integral we have 5 to 6 dt over square root of 4t minus 16, and here we have 6 to 7 dt over square root of 4t minus 16, and here we have 7 times 7 to 8 dt over square root of 4t minus 16, right? Now viewers, let us see the indefinite integral of dt over square root of 4t minus 16, because this integral is involved in these three integrals, right? So we'll first calculate the indefinite integral of dt over square root of 4t minus 16, and this can be written as 4t minus 16 raised to minus half dt, right? So let us put y is equal to 4t minus 16, so dy is equal to 4 dt, and dt is equal to dy over 4, right? So now this integral becomes integral of y raised to minus half. We have dy over 4, right? And we have 1 over 4, and integral of minus y raised to minus half dy, and this is 1 over 4. We have minus half plus 1 over minus half plus 1, and this is 1 over 4 y raised to half, and here we have half, so this is 2 over 4 y raised to half, and this is half times y raised to half, and again resubstituting y is equal to 4t minus 16, so we have half times 4t minus 16 raised to 1 over 2, right? So the integral of dt over square root of 4t minus 16 is half times 4t minus 16 raised to half. So now viewers, let us calculate the indefinite integral of these three expressions, right? So now I1 is we are calculating it separately, so I1 is 5 times the indefinite integral the definite integral of dt over square root of 4t minus 16 from 5 to 6, so we can substitute it here. So we have half 4t minus 16, and the limits are from 5 to 6, right? So now taking half outside, and here we have 1 over 2. So now taking t is equal to 6, so here we have 24 minus 16 half minus we have taking t is equal to 5, so we have 20, 4 5s are 20 minus 16 raised to 1 over 2. So now we have 5 over 2, and this is 8 raised to half minus 4 raised to half. So now we have 5 over 2, and this is 2 root 2 minus 2, right? And now cancelling this 2, we have 5 root 2 minus 5, right? Okay, so this is the value of I1, and I2 is 6 times this definite integral. So we have half, and 4t minus 16 raised to half, and the limits are from 6 to 7, right? So now taking half outside, so we have 6 multiplied by 1 over 2, and taking t is equal to 7, so we have 7 fours are 28 minus 16 raised to 1 over 2 minus, we have 6, so 6 fours are 24 minus 16 raised to half, right? So we have 2 threes are, and we have 3 times 28 minus 16 is 12, so we have 12 raised to half minus, here we have 8 raised to half, right? So now 12 raised to half is square root of 12, which is 2 root 3, and 8 raised to half is 2 root 2, right? So now multiplying these two terms by 3, we have 6 root 3 minus 6 root 2, right? Okay, now let us calculate I3. Now I3 can be calculated as, so I3 is 7 times in the definite integral from 7 to 8 dt over square root of 4t minus 16. So we have half, and 4t minus 16 raised to half, and the limits are from 7 to 8, right? So now we have 7 multiplied by half, and taking t is equal to 8, so we have 32 minus 16 raised to half minus, we have 7, so 7 fours are 28 minus 16 raised to half, and now this is 7 over 2, and we have 32 minus 16 is 16 raised to half minus, here we have 12 raised to half, right? So now this is 7 over 2, and square root of 16 is 4, and here we have square root of 12, that is 2 root 3, right? So now multiplying it by 7 by 2 with 4 and 2 root 3, we have 14, because this is 28 over 2, and here 2 and 2 get cancelled, so we have 7 root 3, right? Okay, so now once we have done all these calculations, let us substitute the values of I1, I2 and I3, right? So now we can write our original integral I as I1 plus I2 plus I3, right? So I1 is 5 root 2 minus 5, and I2 is our 6 root 3 minus 6 root 2, and I3 is our 14 minus 7 root 3, right? So now here we have to collect the like terms, so we have 5 root 2 minus 6 root 2, so we have minus root 2, right? And here we have 6 root 3 minus 7 root 3, so we have minus root 3, right? And here we have 14 and here we have 5. So 14 minus 5 is plus 9, right? So this can be written as 9 minus square root of 2 minus square root of 3, right? So viewers, the value of this integral is 9 minus square root of 2 minus square root of 3, right? So I have solved this problem in a different manner in this video, and you can also watch my previous video for the other method, right?